In this video, I am discussing KSET Mathematical Science previous year questions on real analysis topic limit, continuity and differentiability. This question is 2024 KSET 2024 question. Which of the following is not uniformly continuous on open interval 0, 1? I already discussed this. If you want to practice these kind of questions, join our Telegram group. Link is in the description. Check it once. Next question. In previous video, I discussed this question. That's why I'm moving. Next. This question asked in 2023. Let f of x is equal to sine x square divided by x for x not equal to 0, 0 for x equal to 0. Then, which of the following statement is correct? Asking for correct statement. F of x is continuous and differentiable at x equal to 0, neither continuous nor differentiable at x equal to 0, continuous but not differentiable at x equal to 0, limit. They are talking about limit. First C concept, continuity of f of x at x equal to 0. Limit, continuity means limit x tends to a, f of x is equal to f of a. In that case, function is said to be continuous. Here we want to find LHL, means left hand limit, RHL right hand limit is equal to functional value. That means limit x tends to a minus f of x is equal to limit x tends to a plus f of x is equal to f of a. Then in that situation, a function is said to be continuous. First, C, left hand limit. Limit x tends to 0, f of x value a here is 0, f of x, limit x tends to 0, sine x square divided by x. Put x equal to 0 minus a, means 0 minus h. That means a minus h. X equal to a minus h. A here 0, therefore 0 minus h. Limit. Put x equal to 0 minus h, as x tends to 0, h tends to 0. Limit h tends to 0, f of x is equal to limit h tends to 0. Function is sine 0 minus h whole square divided by x, means 0 minus h. Limit h tends to 0, sine h square divided by minus h. It is in 0 by 0 form, indeterminate form. Applying L'Hospital rule, limit h tends to 0, cos h square. Differentiation of this is cos h square. Chain rule, 2h. Differentiation of h square means 2h divided by differentiation of this is 1. That means minus 1. If you apply limit, cos of 0 is 1 into h value is, if you put 0 into 0 in h place, we get 0, 1 into 0, 0. LHL is equal to 0. Similarly, we can find RHL, we get RHL also 0. Now, limit h tends to limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x is equal to f of a. That means f of 0. Functional value is 0 here. Therefore, this function is continuous. F of x is continuous here. Next, derivability of f of x at x equal to 0. By definition of derivability, limit x tends to, by definition, limit x tends to a, f dash of a is equal to f of x minus f of a divided by x minus a. This is definition for differentiation. We want to find left hand derivative and right hand derivative. If left hand derivative and right hand derivative equal, that also equal to functional value. In that condition, function is said to be differentiable. See here, LHD limit x tends to 0 minus f dash of 0 is equal to limit x tends to 0 minus f, means LHD f of x minus f of 0 divided by x minus 0. F of x here, sin x square divided by x. F of 0 is 0, functional value is 0 divided by x minus 0, x minus 0. Put x equal to a minus h. That means 0 minus h, as x tends to 0, h tends to 0. Here, take limit h tends to 0, f dash of 0, limit h tends to 0, sine of 0 minus h whole square divided by x into x square. That therefore 0 minus h whole square. This is equal to limit h tends to 0 sine h square divided by h square. This is in 0 by 0 form. This is in indeterminate form. That means 0 by 0 form. If we apply L'Hospital rule, limit h tends to 0. This is cos h square into 2h divided by 2h. Again, this is in 0 by 0 form, indeterminate form. Again, if we differentiate this function, we get sin h square minus sin h square minus sin h square into 2h. 2h, put 2h as it is, plus cos h square, differentiate 2h, we get 2 divided by 2. If you apply limit, we get 0 plus 2 by 2. That means LHD is equal to 1. Similarly, we can find RHD. RHD is equal to 1. LHD is equal to RHD. F of x is differentiable. Here, f of x is differentiable. F of x is differentiable at x equal to 0. F of x is continuous and differentiable at x equal to 0. This is right. See, this is KSET 2023 question. Let f from R to R and g from R to R be two uniformly continuous functions. then which of the following statement is not true? They are asking not true statement. C. F plus G is uniformly continuous. This is based on algebra of continuity. Algebra of uniform continuity. Algebra of uniform continuity. Question based on algebra of uniform continuity. F minus G is uniformly continuous. F into G is uniformly continuous. D. 2F plus 3G is uniformly continuous. The concept is one result is there. Product of two uniformly continuous function need not be uniformly continuous. Product of two uniformly continuous functions need not be uniformly continuous. For example, f of x equal to x is uniformly continuous in R. G of x equal to x is uniformly continuous in R. However, f of x into g of x is equal to x square is not uniformly continuous in R. Is not uniformly continuous in R. However, product of two bounded uniformly continuous functions on an interval I is uniformly continuous. For example, x square is uniformly continuous in a comma b or else minus 1 comma 1 or else any bounded interval minus 2 comma 2 10 comma 10 any bounded interval. This product of two function uniformly continuous. Therefore, right answer is option C is the right answer. That means f into g is uniformly continuous is not true. Therefore, right answer is this. All are true. This is also true. Next. This is also 2023 question. Let f be a continuous function from a compact metric space X into a metric space Y. Then which of the following statement is not correct? They are asking not correct. One result is there. See. One result is there. I will discuss this question again in metric space. In uniform continuity, see result. Let X be a compact set. If a function f from x to y is continuous on x, then f is uniformly continuous on x. This is the result. Based on this result, f is not uniformly continuous. This is false. Uniformly continuous on this x. Therefore, this is false statement. They are asking not correct statement. Therefore, this is answer. This is true. This is true. This is true. I will discuss this question again in metric space using properties of metric space. Next, KSET 2023. See, 4 to 5 question. They asked 4 to 5 question only on limit, continuity, and differentiability topic. How important it is. Question is, let f from 0, 1, open interval 0, 1 to R be a function defined by f of x is equal to 0 for x is irrational, 1 by q for x equal to p by q. Here p, q belongs to natural number n and PQ, GCD of PQ is equal to 1. That means co-prime. Then F is continuous at C. This is solution. This is our solution. This is standard, important problem, standard question. Important question. Take this question as a result based. Remember this. See, solution is, first suppose that x, here I am taking a, x equal to p by q and a equal to p by q is any rational number in open interval 0, 1, then f of a is equal to f of p by q. That means 1 by q. They are given p by q in 1 by q greater than 0. Since every neighborhood of a rational number contains infinitely many irrational numbers, therefore for each n belongs to n, because by rational density theorem, this statement is based on rational density theorem, we can find an irrational number an such that an minus a, modulus of an minus a less than 1 by n. That means an lies between a minus 1 by n, a plus 1 by n. The sequence an converges to a. This implies the sequence an converges to a since f of an is equal to 0. F of an is equal to 0 for all n belongs to n. Limit n tends to infinity, f of an is equal to 0, but f of a is 1 by q. This 1 by q not equal. Therefore, f is not continuous at a. F is discontinuous at each rational points. Okay. Next, suppose b is any irrational number in 0, 1, open interval 0, 1, then f of b is equal to 0. Let epsilon is a small quantity greater than 0 be given. By Archimedean property means n is unbounded. By Archimedean property of real numbers, we can choose a positive integer n such that 1 by n less than epsilon. Clearly, there can be only a finite number of rational number p by q in 0, 1 such that q less than n. We can therefore find the delta discriminant greater than 0 such that b minus delta, b plus delta has no rational number with the denominator less than this. That is b minus delta, b plus delta contains only those rational numbers p by q for which q greater than or equal to 0. Thus, when x is irrational, modulus of x minus b less than delta. This implies we taken f of b is equal to 0 here. In the above case, f of x minus f of b is equal to modulus of, this is 0, modulus of f of x is equal to 0 less than epsilon. And when x is rational, that means x minus b less than delta. This implies f of x, modulus of f of x minus f of b is equal to modulus of f of x is equal to 1 by q less than 1 by n less than epsilon, because this is condition. Combining, we have x belongs to R and x minus b less than delta. This implies f of x minus f of b less than epsilon. In both cases, we get less than epsilon value. Therefore, this implies f is continuous at b. That means at irrational point. This implies f is continuous at every irrational point. This is a proof for our question. Now, answer is all irrational points on 0, 1. F is continuous on all irrational point on 0, 1. This is the right answer. Next, KSET 2021 question. This question, I will discuss this question in next Riemann integration. This is derivative on integral sign. This is the question based on derivative on integral sign. Therefore, I will discuss this question on Riemann integrals in the next video. Next, see KSET 2020 question. The number of pairs of integers a and b satisfying 0 less than a less than b and a raised to b is equal to b raised to a is, this is based on f of x is equal to x raised to 1 by x inequalities. If you apply limit on both logarithm on both sides and take a limit, we get inequality. Simply, we can simply, if we don't know about this function, applying logarithm also can solve this question. Now see how. Value is 0 less than a less than b. That means a and b, we want to take a and b value. This equality holds. Take a is equal to 2, b is equal to 4. For practice, you can take other value also. I already tried these values. That's why taking C. A raised to B means 2 raised to 4 is equal to 4 raised to 2. 2 raised to 4 is 16. 4 raised to 2 is 16. This is the only value holds good. That means 0 less than 2 less than 4. This condition holds for this value. That means option B is the right answer for this question. Next question is, this question is KSET 2024 question, important. This type of question will be asked in KSET 2025 exam also. Suppose that G from R to R is a continuous on R and G of x equal to 0 for every rational x. Then, see concept. That question is based on identity theorem. That means if f is a continuous function on a real number R such that f of x equal to 0 for all x belongs to Q, that means rational numbers. That means for all rationals, then f of x identically equal to 0 for all x belongs to R. Now f of x, that means g of x 0 here, this by identity theorem. By identity theorem. Using identity theorem, we can easily solve this question. Identity theorem. This is the answer. Next. See this question. This question asked 3 to 4 times in KSET. A repeated question. This is a repeated question. Question is KSET 2028 question, 2018 question. For all x greater than 0, the inequality e raised to x greater than x raised to t holds if and only if. Condition is if and only if. See, I'm trial and error. I'm taking this value x equal to 1, t equal to 2. That means e raised to 1, 1 raised to 2. That means e greater than 1. E value is 2.73 something. See, this in that case it is true. Next value is by trial and error x equal to 2, t equal to 3. In that case, e raised to 2 greater than 2 raised to 3. That means 2.7 square means 5 something is not greater than 8. This implies t less than e only holds this condition only when t value should be less than e, or else e greater than t. E value should be greater than t. In that condition, this value true. E raised to x greater than x raised to t holds. Or else try this method also. F of x equal to x raised to 1 by x. Apply logarithm. Take these values. In this situation, apply logarithm. You will get required answer. This much for in this video. If you want to practice more questions, join our Telegram group. If you like the video, hit the like button. Subscribe this channel for more videos. Thank you for watching.